Okay, welcome to another edition of Math with Mr. Douglas. What book series is this behind me? Have a think about that. While we talk about math, we're going to look at solving systems of equations two different ways. The first way we're going to look at is solving by the ever-popular substitution, and the second way is going to be by elimination, the fan favorite of every single student I've ever taught. So let's take a look at that, and in the challenge section we're going to take a look at solving a system of equation with three variables. It's going to get crazy. Alright, let's get to it, shall we? Here we go. So we're taking a look at solving systems of equations in two different ways. The first way that we're going to be looking at everything is going to be solving by something that we want to call substitution. And the other way that we're going to learn how to solve is by something called elimination. Now, you might want to split this kind of video up into two different parts and two different settings because it's going to be a lot to kind of take in. So get ready. We're going to do this first and we're going to do this second. And I will give you the preview that most students, when given a choice, will want to choose elimination. It's actually quite a lot of fun. You get to eliminate something, which is kind of always neat to do. And substitution can be a little bit more tedious. So let's get to it, shall we? Solving by substitution. Basically, what you got to do is make a good choice. That's the first thing you need to do. And what I mean by making a good choice is you need to solve one equation for a variable. It doesn't matter what variable, it doesn't matter which equation. But you need to choose wisely. Because there are good choices and there are poor choices. Well, whatever do you mean? Well, let's just take a look at this, shall we? We'll start out with this question. Let's say you had a system. So remember, a system is where we're trying to find the solution where the two lines cross. So negative 6x plus 6y is equal to 12. So that's one equation. And the other one is going to be x plus 5y is equal to negative 14. And I want to know, where do these two lines cross? Now, in earlier videos or lessons, you may have learned how to solve by graphing. You could go and graph these two, but we're going to solve this by substitution. So I need to have one of these equations say x equals or y equals. Now, there is an obvious answer of which one you should do, and hopefully you said I should make the second equation say x equals, because it's going to be really easy to do that. In order to do that, I'm just going to subtract 5y from both sides. So my new equation is going to be x equals negative 14 minus 5y. That means wherever I see x in the other equation, I'm going to put that. So I'm going to go and find x in the other equation. Oh, there it is. And I'm going to substitute this in for that value. So what you end up getting is negative 6 times that stuff that's in green. And you're going to solve this for y. So that green stuff goes in here, right? That's what x was. So it was negative 14 minus 5y. Oh, that's really hard to see. Minus 5y. So you should have to go and now do your math. And there's a couple of shortcuts you could have probably done to solve this one. But I'm going to go really slow. I'm going to expand. I'll give you a hint. If you divide it by 6, it would be a really good choice right now. You could avoid doing the distribution. But I'm going to distribute because majority of students are going to distribute. So negative 6 times negative 14. That's going to give me a positive 84. And negative 6 times negative 5 is going to give me a positive 30y. I still have that other 6y. And of course, this all equals 12 somehow. I'm going to combine my like terms. So I'm going to have that 36y. And then I'm going to subtract 84 from both sides. I'm trying to fit it all in here. Subtract 84. And I'm going to end up with 36y is equal to 112 minus 84. 16, 28. I think, what's that going to be? That's going to be a tough one. I also have to go and grab it from my calculator. But I think that is going to be, what is that? 16 and 12. So 28. 20 like that. And then I divide both sides by 36. Now, it seems to me like something has gone wrong here. Has something gone wrong? It seems like I've done something wrong. What did I do wrong? Minus 14 minus 5y. I'm now talking through everything because this does not equal what my answer key is saying. It is possible my answer key could be wrong. That is a possibility. Oh, of course, I had extremely bad handwriting. This isn't 112. Of course not. It's just 12. Let me go and fix that. There we go. Let's fix that a little bit. So that should say 12. There we go. What's 12 minus 84? That is going to be negative 72. Whew. Okay, you're probably screaming at the screen right now going like, no, Mr. Douglas, obviously it's negative 72. There we go. Divide both sides by 36. So divide both sides by 36. And hopefully you see that will be y is negative 2. Boom. There we go. Yay. Okay, so we have y equals negative 2. That's exciting. Now you have a choice. You need to substitute that negative 2 back into either of the equations to solve. It doesn't matter. Now this is getting pretty messy right now. So I'm just going to go and erase some of this. And I'm going to put that negative 2 into the very first equation. I'm going to go and put that in there. So what I'm going to get is negative 6x plus 6 times negative 2 equals 12. And I'm going to go and solve for the x. So I get negative 6x minus 12 equals 12. So negative 6x equals 24, and x will equal negative 4. Boom. You've got both of your values for x and y. So your final answer, of course, is the two lines, the system, they cross at negative 4, negative 2. Now you can go and check that, put them back into the equation, and both equations would be absolutely true. Your screen is extremely messy, but hopefully you've taken extremely good notes on this example. Let's get rid of that one and take a look at another one. So the other one that we will be taking a look at will be the following. Let me get a nice golden color here. And let's say we had negative 2x plus y is equal to 16. And the other equation is going to be a negative 5x minus y equals 12. Again, you want to make a choice to solve one of these equations for x or y. Now you're probably hopefully thinking that you should solve one of these equations for y because y is all by itself. I'm going to convert this one to say y equals. And if I want to make that say y equals, I need to go and add 2x to both sides. So 2x plus 16 is the exact same equation. I've just rearranged some things. I'm going to take this value for y, and I'm going to put it right in here. Now this one obviously has a common kid mistake built into it. And the common kid mistake, of course, is forgetting about that minus sign that I just wrote. So don't forget about being really careful with some of those. And now I'm going to go and distribute. And when I distribute, I'm distributing that negative sign. And I'm going to get something that looks like that. I'm going to combine my like terms and add 16 to both sides. So I'm going to get negative 7x is equal to 28. So x is negative 4. Now, you're halfway done. You're halfway done. Now you take this negative 4 and you put it to wherever you want to. So I'll just go and I'll put it right there. So now what I'll end up getting is negative 2 bracket negative 4, that's the value for x, plus y is equal to 16. So I get positive 8 plus y equals 16. I'm going to subtract 8 from both sides, and my y will equal 8. So my final answer is going to be negative 4, comma 8. That's where those two lines will cross on the Cartesian plane. So that's how we go and we solve by substitution. Now you might want to pause right there, because the next one we're going to be looking at is going to be elimination. Now we're going to look at solving systems of equations by elimination. And this is my favorite. So the idea of elimination is you're given a system of equations, so two lines, and you're asked to eliminate by adding or subtracting one of the variables. So let me just get my couple of equations here so you can see that first one. And you want to line up always the x's and y's. So it looks like that. So rearrange things if you need to. And what you want to be doing is saying, now, can I add or subtract? So this is like old school. Like, remember when you're in elementary school and you're doing things like 2 plus 3 is 5. Okay, so that kind of stuff. So that's kind of what we're going to be doing, right? So you line everything up really nice and neat. And then you ask yourself, if I add or subtract, can I eliminate something? You want to look at the coefficients of the variables and to see if they're the same. Oh my gosh, the y's are exactly the same. Ask yourself, if I add or subtract, would I make this become 0y? So if I added, this would be negative 7, that is negative 7, plus positive 7. That would give me 0y. That would eliminate my y's. They would all disappear. You don't need to write that. And if I went and added this, negative 3x plus 2x would give me a negative x. And of course, we're still adding, so this is negative 7 plus 14. So that would give me 7, just like that. So in other words, you would have, negative x equals 7. So x would equal negative 7, because you always need to solve for that positive variable there. Once you had that, once you've eliminated one, now you have the great choice of putting that back into the other equations to solve for y. So again, now you're going to go and substitute. That's why we teach substitution before elimination. It doesn't matter where you're going to put it in. I'm going to put it into right here, just for fun. So you'd end up getting 2 bracket, because whatever x is negative 7, plus 7y equals positive 14. So you get negative 14 plus 7y is 14. I'm going to add 14 to both sides. I'm going to go and add 14 to both sides. So that would leave me with 7y is equal to 28. So y is 4. So my final answer, the place where the two lines cross, is negative 7, comma 4. And that's the solution. So that's the first version of elimination, when it's nice and easy. It's like, because that was pretty easy, right? Because these were already the same coefficients. But what happens when it's not? Because teachers are probably going to give you one of the next following two scenarios. So here's our other system. So the other one is x plus 6y. X plus 16y equals 15. And the other one is 5x plus 8y. Oops, let's go and use a different color. We like using lots of colors, don't we? 5x plus 8y is equal to 3. And that's a y. There we go. Now, when you look at these, ask yourself, do any of the coefficients, are any of the coefficients the same? Well, this is 1 and 5. That's not the same. 16 and 8, not the same. Ask yourself, could you multiply one of the equations to make the coefficient the same? Well, hopefully you're saying, if I multiplied this whole thing by 2, everything by 2. So everything by 2. Well, then, fancy that, I would have the y's being exactly the same. So if I multiplied this all by 2, I would have 10x plus 16y equals 6. And my other equation, remember, was x plus 16y equals 15. Great. Now I can go and eliminate. And you ask yourself, would you eliminate by adding or subtracting? I'm going to subtract this time because 16 minus 16 is 0. So 10 minus, this is 1, would leave me with 9x. And 6 minus 15. So 6 minus 15 would give me negative 9. So x would then equal good old negative 1. Okay, so now we're halfway done. You're going to take that value and insert it into one of the original equations. So it doesn't matter which one you're going to go and do. I'm going to put it into the first one, because that just makes sense, I think. So that would be, that negative 1 for x plus 16y equals 15. I'm going to add 1 to both sides. So I would have 16y equals 16. So y equals 1. My final answer is where those two lines cross is the solution, and they cross at negative 1, 1. That's elimination when you had to do a little bit of multiplying. But what if you have to do a lot of multiplying? I'm glad you asked. The final example, maybe you're going, hooray, there's only one more example, is when you need to go and multiply both equations in order to get something that is the same variable. So my next one is negative 2x plus 4y equals 6. So if you look at these, the coefficients aren't even close to being the same. But you need to ask yourself, how could I multiply to get them the same? So think of the lowest common multiple of, say, 5 and 2. So the LCM of 5 and 2 is going to be 10. So what I'm going to go and do is I'm going to go and I'm going to multiply this entire equation by 2. And I'm going to multiply this entire equation by 5 because I want to eliminate the x's. That's what I decided to do. So when I go and do that, and I'm going to get a completely different equations. So, oops, I'm going to get 10x. Let's see. Let's get the right colors here. I'm going to have 10x now minus 12y equals negative 22. And in my other equation, I'm going to have negative 10x plus 20y is equal to 30. Great. Now I can go and eliminate my x's. And how can I do that? By adding. So I'm going to go and add. So that's going to make my 0x. What's negative 12 plus 20? Is going to be 8y. I'm going to go and add this, and that's going to be just simply 8. So y is 1. Now, I need to go and take that value for y and put it back into one of the equations. I'm just going to go and put it into, I don't know. I'm going to put it into this one right here. That looks cool. So I'm going to get negative 2x plus, basically it's going to be 4, right? Equals 6. So I'm going to subtract that 4 from both sides. So I get negative 2x is equal to 2. So x is going to be equal to negative 1. Put it all together, and you've got a solution. The solution of this system is negative 1, 1. That's where they both cross. Whoosh. That is solving by elimination. So you've seen the kind of the gradual build-up for that. And there you go. So what book series is this one? Do you have some guesses? I'll give you a hint. The best character in the series is called Wolf. Okay, we're going to look at solving systems of equations in 3 variables, x, y, and z, not z. Let's get to it. Here we go. Z or z? That's always the question, isn't it? Obviously the answer is Z, but it does create always a fun debate in class. What happens when you have three variables, like X, Y, and Z? How does systems work then? Well, it's a pretty complicated topic, to be very honest. We're going to take a look at the situations where you get linear solutions, basically. And you'll dive more into this when you get into high school, probably. You're probably in maybe middle school watching this. So we're going to take a look at some basic situations. So it can get more complicated, do realize that. I'm going to give you a strategy that works pretty well. I think there's always some different ways to go and solve this. And make sure you're very organized and you have a lot of paper. And I'm going to actually change my example, my first example. Let's do the first example so it looks like this. So we're going to have three equations with three variables. So the first one's going to be X plus Y plus Z is equal to 0. What is equal to 0? Doesn't seem fair. And then the next one is going to be a X minus 2Y plus 2Z is equal to 4. 4 there. And my final equation is going to be X plus 2Y minus Z is equal to 2. Okay, so there you go. And you're like, where do I start? You're going to use the ideas of elimination, substitution, everything but graphing. And I'll tell you what you're going to do right now. And hopefully the colors will help you. You're going to combine these in the following manner. You're going to choose the first two equations like this, and then you're also going to have the second two equations kind of like this. I'm trying to find a good color and to make it very obvious for you guys. Now, you can see that the blue box and the purple box, they share the green equation. You need to make this so the two boxes share one of the equations. And what you need to do is eliminate the same variable in both boxes. So let's take a look at what happened to our blue box. So our blue box looked like this. X plus Y plus Z equals 0, as well as X minus 2Y plus 2Z equals 4. Okay, that was my blue box. The purple box was X minus 2Y plus 2Z is equal to 4, and X plus 2Y minus Z equals 2. So in the blue equations and the purple equations, we need to figure out, I want to eliminate the same variable. What do I want to do? I'm going to go and I'm going to eliminate the, hopefully you all said X's. Okay, I'm going to eliminate the X's. So let's go and eliminate the X's. I don't know, I'll do this box first. Why not? Let's just go and eliminate it. So I'm going to go and eliminate the X's by subtracting. So this is minus 2 minus another 2, so don't make that mistake. So it's minus 4y. 2 minus z, so that's going to be positive 3z. And 4 minus 2, which is just going to be 2. Over in my blue, I'm going to subtract again to solve. So my x's are gone. And y minus minus 2, which is going to be 3y. Z minus 2 is going to be negative z. And this is going to be negative 4. Okay. So now we have two new equations that look like our basic systems, don't they? They're two variable systems of y and z. Easy peasy. So what you're going to do is you're going to take those. So you're going to take those and you're going to solve them like you would any other two variable system. And what you're going to get is, and this is why it's great, what you're going to get is a solution for y and z, and you'll almost be there. So let's go and do that, shall we? Like you had a choice. So what did we have there? We had 3y minus z equals positive, oops, it wasn't positive 4, it was negative 4. Gosh, don't do that now. Equals negative 4. And you had negative 4y plus 3z is equal to 2. So we're going to go and eliminate those. I want to eliminate. I love eliminating. And to do that, do I want to eliminate? Yeah, I want to go and eliminate. I'm going to go and I'm going to eliminate the y's. So that means I'm going to multiply everything by 4. And then everything by 3 down here. So my new equations are going to be 12y minus 4z equals negative 16. And negative 12y plus 9z equals 6. Let's go and eliminate by adding. So we're going to go and add those up. So I think we get, 5, that's a z. Seriously, it's a z. Equals negative 10. So z is going to be negative 2. Okay. We have 1/3 of the answer, negative 2. Woohoo! Let's go and put it back into an equation. Now I see that, and that's where I'm going to stick it in. So 3y minus 2. Don't be crazy and forget about the minus, because you don't want to do all this work and then accidentally make a mistake, right? That would be sad. Sad, sad, sad. What? Y? Y is negative 2? Do you think x is negative 2 as well? That'd be crazy, wouldn't it? Like they're all negative 2. Okay, so you got y and you got z. That's awesome. In order to solve for x, now you just need to go and put it back into any equation you want to. Do you remember the original equations? Do you? Hopefully. You probably remember this one. X plus y plus z is 0. So if everything is negative 2, right? So this is like x plus, so this is like negative 2, and this is negative 2. So x basically minus 4 equals 0. So x is 4. Woohoo! What is our solution to this 3 variable? It is 4, comma, negative 2 and negative 2. Hopefully you're like, yes, I got it. That was awesome. So there you go. That's solving a 3 variable system of equation using that method of boxing the 2 equations. It's a really efficient way to go and solve them. And there might be some other ways that you've been taught or have seen, but I've always found that way to be a really good strategy. There you go. The Lunar Chronicles is obviously the answer. One of my favorite series that I've been reading lately. Hope you've had a good time solving systems of equations 2 different ways and taking a look at tackling those complicated 3 variable situations. Alright, you should be set for solving. Good luck, and may the force be with you. Does that work for this? I don't know. Alright, till next time.